Welcome to the Deep Dive, where we tear into a mountain of information to deliver the key insights directly to you. Our mission is to transform complex sources into crucial, memorable knowledge. And today, we're taking a thrilling intellectual detour back to the 1st century CE, to the intellectual heart of the ancient world, Alexandria, Egypt. We are diving deep into the mind of Hero of Alexandria, a figure who was part mathematician, part engineer, and, well, arguably the greatest technological prophet of his age.
That's absolutely right. Our sources paint this picture of a man who bridged, the theoretical rigor of Greek geometry with just groundbreaking mechanics.
And that's what we want to show you today, right?
Exactly. We want to show you how Hero systematically defined the foundational elements of engineering, the simple machines, while at the same time inventing devices that were, for all intents and purposes, modern technology just 2,000 years early.
And to put this in context for you, we aren't talking about some simple clockmaker. We're talking about someone who utilized an eclipse reference in his treatise dioptra just to date himself around the 1st century CE. So he was a serious scientist. He stood on the shoulders of giants like Euclid and Archimedes.
Mm-hmm. And he didn't just stand there. He organized the landscape beneath them. Hero is credited with systematizing the 5 simple machines that really define basic engineering: the lever, the winch, the pulley, the screw, and the wedge. He basically gave the world its foundational toolkit.
It's just so hard to believe this same person who was formalizing structural engineering was also, he was dabbling in what looked like performance art.
Well, yeah.
Was his reputation taken seriously as an inventor, or was he seen more as, a spectacle maker?
The beauty of Hero's work is that the two roles were completely intertwined. He understood that demonstrating scientific principles through spectacle it made them understandable and memorable. He was a real pioneer in applying pneumatics, the science of air and pressure, to create effects that looked like pure magic.
Okay, here is where the source material gets just captivating. Let's focus on the automata, because these were things designed for pure theatrical delight. Imagine sitting in a theater and watching a completely mechanical puppet show that could run for almost 10 minutes. This was ancient programmable entertainment.
It was. It was essentially the world's first cinematic experience, all powered by clockwork. The system was remarkably complex for its time. It operated with a whole series of ropes and knots and counterweights all wrapped around this rotating cylindrical cogwheel.
So as the cylinder turned, it was sort of like a computer program.
In a way, yeah. The ropes were released or pulled in a pre-programmed sequence, which dictated all the movements of the puppets.
And he added sound effects. I love this part. We know from the texts that he timed the performance perfectly, including a mechanism to produce the sound of thunder.
Right, by having metal balls mechanically timed to drop onto a hidden drum.
It wasn't just movement. It was a fully immersive, multisensory experience.
And this same approach was applied to religious architecture, to instill awe. Think of temple doors that would just swing open automatically when a priest lit a fire on the altar.
How did that even work?
He was using the rising steam or expanding air from the fire to trigger a hidden mechanism. Or statues that would appear to pour wine or milk thanks to invisible siphons and hidden tanks, all connected by principles of differential air pressure.
He was literally engineering miracles. And we can't overlook the fact that he designed the world's first documented use of wind power, a wind wheel used to operate a pipe organ. It just shows a mind that was constantly seeking new ways to convert natural forces into mechanical action.
And the documentation of these marvels is a story in itself. Hero's treatise describing these devices, the Pneumatica, was wildly popular. It described all these apparatuses for natural magic, and over 100 manuscripts survived the Middle Ages. The earliest one we have dates from the 13th century.
People loved the magic.
They absolutely did. It proves that the world was fascinated by the magic of his mechanics.
That's a great transition, because Hero's legacy isn't just in showmanship. He was also a profound utilitarian engineer. So walk us through his most famous practical invention.
Right, so we're talking about the world's first automatic vending machine. It was designed to dispense holy water in temples. And it's just a genius piece of weighted mechanics.
Okay, how did he achieve that level of automation 2 millennia ago?
The mechanism is it's so elegant. You would insert a coin, probably a drachma, into a slot. The coin wouldn't drop straight to the bottom. It would fall into a little pan attached to one end of a balanced lever.
And the weight of the coin would immediately tilt that pan. Right.
Exactly. That tilting motion would pivot the lever, which then opened a valve connected to the water reservoir above. The holy water would then flow out into the waiting hands of the devotee.
And the brilliance of it is the timing. I mean, the water didn't just keep flowing forever.
No, absolutely not. As the pan tilted further down, the coin would inevitably slide off and fall away. Once that weight was gone, a precisely calibrated counterweight on the other side of the lever would immediately snap it back to its original position,
Slamming the valve shut.
slamming the valve shut and cutting off the water flow. It was a perfect, self-regulating time-release system.
Imagine seeing that in the first century. That level of mechanical responsiveness must have seemed, I don't know, absolutely futuristic. And beyond hydraulics, he also formalized critical mathematics. He gave us the formula for calculating the area of a triangle using only the lengths of its three sides, a breakthrough that simplifies geometry immensely.
He was a genuine polymath. I mean, his engineering focus also yielded these foundational tools for, like, urban development and infrastructure. We have the dioptra, which was a complex sighting instrument for precise land surveying, allowing engineers to determine elevation and distance. And the odometer, used to accurately measure distances traveled, which is essential for mapping and planning roads.
What's fascinating here is the stark contrast in how his knowledge was passed down. As you mentioned, the Pneumatica, his Book of Wonders, was copied extensively and survived through dozens of manuscripts.
But then you look at his Mechanica. This was the serious textbook, dedicated to the theoretical knowledge and practical skills for architects and heavy builders, how to lift massive weights, how to design robust structures.
And that profound work on structural engineering, it survived through only a single complete text.
That's the intellectual tragedy and miracle all at once. The complete text of Mechanica only survived because of a dedicated Arabic translation made by a man named Costa ben Luca between 862 and 866 CE.
Wow. So the serious engineering principles were primarily preserved not in Europe, but in the non-Western world.
That's right. It tells you something. The world valued the technological magic far more than the fundamental mechanics.
And that gap in preservation, it raises a critical question. What happens when the most revolutionary invention is viewed purely as a source of wonder, not as a tool for industry? This leads us directly to Hero's ultimate technological marvel.
The aeolipile, the first steam engine.
Walk us through the device itself. It sounds deceptively simple when you read about it.
It is. It consists of a metallic hollow sphere, suspended so it can rotate freely, and it's partially filled with water. Two curved, opposed tubes project from the sphere, and crucially, they point in opposite directions.
And the operation is straightforward. You just apply heat to the water-filled sphere until it boils.
Right. The steam pressure rapidly builds up inside the sphere and is forced out through those two curved, opposed nozzles. This creates a reactive thrust. It's a core principle of physics applied to a rotary machine, which causes the sphere to spin and spin rapidly. It's the conceptual ancestor of the turbine.
So we have a functional high-speed motor powered by thermal energy invented in the first century. That is just staggering.
It really is. And modern reconstructions, they confirm the power of this concept. These devices could achieve anywhere from 1,000 to 2,000 revolutions per minute. It was a genuine motor, capable of sustained mechanical output, anticipating the 19th century Industrial Revolution by almost 1,800 years.
So the big question, why didn't the ancient world use this? Why wasn't it scaled up, put on a boat, or connected to a grinding mill?
Well, the sources tell us that Hero described the aeolipile in the Pneumatica, his Book of Wonders, as an experiment in technological marvel. It wasn't designed for industry or utility. It was a demonstration of the power of steam, a purely academic toy. And you combine that with the lack of economic necessity, the availability of cheap slave labor, and the metallurgical limits of the era. The ancient world just wasn't ready to convert heat into large-scale mechanical power.
That decision, or maybe non-decision, to keep the steam engine in the realm of spectacle is one of the great what-ifs in history. But let's use Hero's core philosophy to look forward. His ultimate passion was for devices that were auto-alimentati, self-powered, silent and marvelous, running without animal or human traction.
Right. And if Hero were alive today, he would be captivated by any technology that embodies that silent, efficient, self-managing ideal.
So if Hero valued scalable engineering, silent movement, and stored energy, what modern technology do you think would best capture his imagination?
I don't think it would be a single gadget. I think it would be the entire concept of the modern electric vehicle platform. Hero would see it as pure, practical magic.
How so?
Well, consider the core principles. It's silent, it requires no horses, no smoke, it's clean and efficient. It uses advanced battery storage to run on energy that seems almost infinite and just stored, fulfilling that auto alimentati dream. The energy management system, which silently coordinates power delivery and braking, would seem like a perpetual, self regulating machine to him.
And he'd probably also be fascinated by the idea of programming those devices. The fact that a vehicle can receive wireless software updates, changing its function without physically altering the machinery. That mirrors his own sophisticated, pre-programmed automata.
Exactly. And the fact that these electric systems are often built on modular, scalable platforms, meaning the same basic engineering can be adapted to vehicles of different sizes, that is exactly in line with Hero's principles of systematization from his Mechanica. He was all about defining a standard, repeatable mechanism.
What a legacy. Hero of Alexandria managed to connect the most rigorous mathematics and foundational engineering with the sheer delight of theatrical deception, leaving us just this staggering body of work. And his survival story, partially saved by the world's love for magic and partially saved by dedicated translations centuries later, is a testament to the unpredictable nature of how knowledge gets passed down.
He really showed the world what was mechanically possible. He proved that massive power could be generated, even if the world at the time didn't have the vision to shift that power from scientific wonder to industrial utility.
Considering the hero invented a functional steam engine prototype purely as a demonstration, just imagine how differently the ancient world might have developed if his focus had been shifted from spectacle to mass utility. And that raises a fascinating question for you. What single technological leap do we view today? A concept like, say, quantum computing or deep robotics as just a toy or a purely academic demonstration that might actually define the next industrial revolution? That's something for you to mull over after this deep dive.
And if you learned something surprising today from this story of the ancient world's tech wizard, please make sure to follow the channel to catch our next exploration.
We'll see you next time.